Hello, ladies and gentlemen, and welcome back. Welcome back. Root Beer here, looking at question number 12 in this video on our Fermat paper. In the given 5x5 grid, many squares can be formed using the grid lines. Here's one. Here's one. You could a big one up here like this. How many of these squares contain the shaded 1x1 square? Okay. So, what can we do? It's a counting problem. We want to make sure we're counting everything that we need to count and none of the things that we don't want to count. Now, with a question like this, there's also the chance, is it easier to count the number of squares in total and then subtract off the squares that don't contain our shaded square? Or do we really just want to try and count our shaded square? And if that's the case, if that's the one I am leaning towards, how are we going to do this in a nice systematic way so that we don't miss anything? The hardest thing to do in a counting problem is to make sure you are counting everything that you want to count and counting them exactly once. You don't want double counting, and you don't want to have missed something. Okay. So what I might try and do is have an organized approach. The squares that we can make using the grid lines can have size 1x1, or 2x2, or 3x3, or 4x4, or 5x5. Now, the most obvious one is, well, there's going to be one 5x5 square, and of course it will contain our grid square. So there's one of them right there. Now, if we're looking at 1x1s, really you could just draw the single 1x1 around it. That's the only 1x1 square that's going to contain our grid. So there's another 1. So we're up to 2 already. Now this isn't inspiring, because if you take a look at the answers, we need at least 11. At least 11 or we aren't doing well. So now let's think, okay, 2x2s. Well, a 2x2, they're kind of small. And so when I think about a 2x2, there's sort of 1, 2, 3, 4 positions that could be my shaded square. And if we look, there's 1, 2, 3, and 4 ways to get that shaded square inside a 2x2 position. And once the shaded square has had its spot inside the squares picked, that sort of fixes where it's going to be. So when we move on to the 3x3s, well, again, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 spots it can be. Could it be this one? Can we overlay things on our grid properly to get a 3x3 where the right side middle corner is my shaded square? And here's where we start to run into problems, because obviously if this kept working, then you'd have 25, not one 5x5 grids in your 5x5 category. But if I try and place a 3x3 grid, or a 3x3 square, I'm going to be off the grid lines, which is going to cause a problem. So we can't have that. So the fact that the shaded square is 1 away from each side here sort of limits our possibilities. Now we could have this corner, or we could have something like this, but the second you move into the third column, then suddenly my shaded square is more than 2 spaces away from the side. That side's going to hang over. So, can't have that one. But we can have this one and this one. But now if we were trying to do something like 7, again, we're too far down, and we're going to get some overlap here. So we can't do 7. And that means we're only going to have 4 of these 3x3s. Okay, 1, 4, 4, 1. So we've got a total of 10 here. That's good. There should be at least one 4x4 that works. Question is, are there more? And absolutely there are. So now we start thinking, okay, how can I place a 4x4? And the same sort of restrictions will apply to the 4x4s as applied to the 3x3s. I don't know, we'll use purple. So we get our shaded square, and we think mentally about what a 4x4 looks like. And you might ask, well, could I get my shaded square be over here? Well, no, because that would mean you get quite a bit of overhang over here, and placing the square down there is not a square using the grid lines. So that's out. Similarly, I'll use a little X to say no, we can't get there. So you can't get anything over here. You can't even get anything over here. It's just like the 3x3s. Okay. You're limited down to this range, because otherwise you'll get overhang. Okay. But you do have to check that each one of these does work. Okay. So yes, we can get this one, and we can get this one. Shift over a bit. You get this one, and you can get this one as well. So yeah, we do get all four there. But this is why the 5x5, it's not just 1, 2, 3, 4, because you can't actually get a 5x5. You have to start worrying about overlapping on the other side. So we get 1, 4, 4, 4, 1. That's a total of 14. So 14 is going to be our answer here. And that's going to be E. That's what we bubble in. That's what we write down. And we move right along to question number 13. I'll see you for that next time.